Hey YouTube, welcome back. Have you ever wondered how databases handle thousands of concurrent transactions without creating chaos? Today, we will unravel the mystery of isolation, a fundamental property in database system that ensures transactions don't interfere with each other. First, as always, we answer the question of what is isolation? Isolation means that every transaction is executed independently of others. It's like ensuring that every person in a crowded room has their own private conversation, no interruptions, no mix ups. Okay, but what are the challenges of concurrent transactions? When multiple users perform transactions simultaneously, data conflicts can arise. To solve this, databases employ techniques like two-phase locking and snapshot isolation to solve that. So we need to dive into how these mechanisms work. First, we talk about the two-phase locking. Two-phase locking, this method ensures that transactions acquire and release locks on data in two distinct phases. We have the growing phase and we have the shrinking phase. As you can see, it's growing here and it's shrinking here. Sorry, shrinking here. Let's talk about the growing phase in the beginning. The transaction acquires all necessary locks to perform its operations. Imagine this as collecting all the keys before you unlock multiple doors. We have the locked point, which is will be exactly here. This is the peak of the process where all locks are held before any are released. The second thing, we have the shrinking phase, this one. After completing the operations, the transaction releases the locks one at a time. This prevents conflicts by ensuring no overlapping writes. Okay, let's talk about the snapshots, like snapshot isolation. Um, let's say that we have multiple concurrent versions, like a multi-version concurrency control technique that shines during reads. It's like taking a photograph of the database at a specific point in a time. Let's understand how it works. When a new write occurs, the old version, okay, the old version of the data isn't overwritten. Instead, a new version is created complete with a timestamp generated by TrueTime technology. When someone reads the database, they get the specific snapshot version relevant to their transaction. But why this is powerful, why it's important? Snapshot isolations allows for lock-free reads, meaning ongoing writes don't block read operations. Older versions are eventually cleaned up to save storage space. A real-world example of that, like how to do two-phase locking and snapshot isolation work together in real time. Let's consider a high-traffic e-commerce platform. The two-phase locking ensures that customers don't overwrite each other's order during a flash sale. The snapshot isolation allows analytics teams to generate sales report without interrupting ongoing transactions. So it's a pretty smooth process. So in summary, the two-phase locking manage concurrent writes, while snapshot isolations reads efficiently and effectively. Together, they maintain database integrity and the performance as well, even under heavy traffic. So that's it for this video, and see you guys in future problems.